Good morning, this is Key Concept 2, Target D. Your objective today is I can identify the vertex of quadratic in vertex form. So, when we have looked at quadratics in standard form, but there are other ways to write quadratic functions. Here is the standard form, the ax squared plus bx plus c, and this is something that we've looked at a whole lot. But you can also write quadratics in vertex form, which is written as a times the parentheses x minus h squared plus k. Now, the reason why this is named vertex form is because it tells us exactly where the vertex is. The vertex is the point h comma k. So you'll notice in here, we have a minus h there, and then we have a plus k at the very end. So let's go ahead and show you how we can use the vertex form to identify the vertex. Here is x minus 2 quantity squared plus 3. Where is the vertex? Well, here the h value is 2. The k value is 3. So I should expect the vertex to be at the point 2, 3. And if you look at this graph that I have over here on the right, that is exactly where the vertex is. Now you might be sitting there thinking, wait a minute, it says minus 2. So why did he write positive 2? And why is the vertex positive 2? And then when I look at the graph, the vertex is positive 2. Be careful of h. When you look at the formula, it says x minus h. Another way to think about minus and subtraction is the opposite of. So the opposite of h there. Because of that, because the formula calls for x minus 2, I'm thinking the opposite of negative 2, which is 2. So if you see x minus 2, then h is 2. If you see x plus 2, then h is negative 2. So I'm going to write h is opposite of what's written. Specifically, what operation? So if you see addition, you think h is negative. If you see subtraction, h is positive. Let's look at some examples here just to kind of get you prepared for this mindset. Here I have x minus 1 quantity squared minus 4. So again, looking at our formula, x minus h to the power 2 plus k. So I see minus 1, which means h is equal to positive 1. Remember, it does the opposite. And k is the exact same. So my vertex here is 1 comma negative 4. About this next example, I see x plus 5. Okay, I see plus 5 positive, right? So I'm thinking the opposite then, which is minus. And then k, I see this plus 2 at the end there. We should probably highlight these. So then my vertex is negative 5 comma 2. That leads to our last example, x plus 9 quantity squared minus 3. I see plus 9, so I know h is the opposite, which is negative 9. And then k here is just negative 3. K will never lie to you. K is always exactly how it is written. So that's how we find the vertex form, or the vertex from looking at the vertex form of a quadratic.